In this lesson, we are going into a new chapter called the symbolic math. In many applications in mathematics, science, and engineering, it requires symbolic operations rather than the normal operations. So let's see how can we perform symbolic operations in MATLAB. First, we need to know how to create a symbolic object. For example, if we want to assign A to the symbolic object, we will type in A equal to sim. And if we want to assign A, the object is A to the variable A. So this is how we type in A equals sim A as a string. When we press enter, we see that A is equal to A. And in the workplace, you see A is 1 by 1 sim, which means that A is a symbolic object. We can assign, for example, BB equal to sim in a string BB. When we press enter, MATLAB says BB is equal to BB, also as a symbolic object. And we can assign, for example, G to a sim of, let's say this is gamma. When we press enter, MATLAB says G is gamma, also a symbolic object. We can also assign number as a symbolic object. For example, we assign C is equal to sim of 5. So now C has a value of 5, but it is also a symbolic object. See here. Maybe we assign D is equal to sim 7. So we get D is equal to 7. This is totally different. If we say E is equal to 13, this is not assigning a symbolic object, but this is a normal scalar number. So if you see here, when you press enter, E is equal to 13, there is a space created by MATLAB to indicate that this is a normal number. You see here, also in the workspace, E is 13. But up here, D is equal to symbolic object of 7, D is 7. There is no space for number 7, and D here is given by 1 sim in the workspace. So this is to differentiate which one is a symbolic object, which one is not a symbolic object. This is just a numerical variable. E is equal to 13. So we can also assign multiple variables by typing in the command sims, which followed by the variable. So let's say we want to define Y, Z, and D. So when we press enter, MATLAB says that Y, Z, and D is now a variable. It's now a symbolic object. Okay, so let's clear this and define again. Now we want to see how can we define an expression, a symbolic expression. So I'm going to type in here, creating a symbolic expression. So let's define several variables. I want to define A, B, C, X, and Y. So when I press enter, you see A, B, C, X, and Y has been created in the workspace. These are all symbolic objects. Now we want to define F. The expression is F equals to A times X squared to the power of 2 plus B times X plus C. So this is our expression, and all variables within the expression has been defined up here. So when we press enter, we see that F now has a value of AX squared plus BX plus C. Okay, we can also define, for example, G that is equal to 2 times A divided by 3 plus 4 times A divided by 7 minus 6.5 times X plus x over 3 plus 4 times 5 over 3 minus 1.5. So when we press enter, we get this equation here, 26a over 21 minus 37x over 6 plus 31 over 6. So from the expression that we have entered up here, MATLAB automatically simplify it to become in this term here. So this is an example of how we can create a symbolic expression in MATLAB. Now let's clear this and see how can we put exact value in symbolic operations. Now let's say we define A is equal to sim of 3, and then we define B that is equal to sim of 5. So we have here two values A, B, and we write an expression E is equal to B divided by A plus square root of 2. So when we press enter, we see the expression has been displayed by MATLAB. E is equal to 2 to the power of half or square root of 2 plus 5 over 3. 5 over 3 comes from B over A because we define up here B is equal to 5, A is equal to 3. So let's say we now define C is equal to 3, which is not a symbolic object. D is equal to 5. When we press enter, you see that C and D is equal to 3 and 5. These are not symbolic objects. And if we define an expression, F is equal to D over C plus square root of 2, for example, when we press enter, you see the difference here from what we have above, that now MATLAB displays a number, an approximated number. This is not an exact value. This is an approximated value because this expression does not contain any symbolic object. It contains C that is equal to 3, D is equal to 5, and square root of 2 is also a numerical value. So MATLAB will generate a numerical value as an answer. Whereas the top example here, example above, we have 3, we have A that is equal to 3, a symbolic object. We have B that is equal to 5, also a symbolic object. So E is displayed in form of an exact value. So this is what we call as an exact value. This is what we call as an approximated value. Okay. What if the expression contains both symbolic object and also numerical value? Let's say we have G, another variable or another expression that is equal to D over A plus square root of 2. Now in this case, A is a symbolic object that has a value of 3. D here is a numerical value that has a value of 5. Square root of 2 is also a numerical value. But we have A here that is a symbolic object. So when we press enter, we still get an exact answer, exact value. Let's look at more example. For example, we have H that is equal to 10 over 3. So MATLAB will display 3.333. Okay. And then we say that K is equal to symbolic of 5. K is a symbolic object that has a value of 5. And M is equal to symbolic object that has a value of 7. Okay. Now we say that our expression P is equal to K over M plus H. So remember that K and M are symbolic objects, and H is a numerical value that has a value of 3.333. So when we press enter, we see that MATLAB displays an exact value, 85 over 21. MATLAB does not give an answer in form of approximated number with decimal places, but it gives an answer in form of a fraction to indicate that this is an exact value. So we can ask MATLAB to produce an approximated value out of this exact value that has been created by using a double command. For example, here Pn will be equal to double of the variable P. When we press enter, we see that Pn is now 4.0476, which is the approximated value of 85 over 21. Okay, let's look at another example. Let's say we have y that is equal to symbolic of 10. We type in directly and multiply with cosine of 5 times pi over 6. For example, y is equal to symbolic of 10 times cos of 5 times pi over 6. So symbolic of 10 is of course a symbolic object. Cos of 5 times pi over 6 is a numerical value. So when we press enter, definitely we will obtain an exact value because we have a symbolic object involved in the expression. So again, if we would like to know the approximated value, we can always use the double command. That is double of y, what we have up here. When we press enter, we get the value of we get the numerical value or approximated value of this minus 5 times 3 to the power of half. So we get minus 8.6603. Okay, now let's define a few more symbolic objects: x, h, w, y, d, and t. So it appears, all of these symbolic objects appears in the workspace. Now we define our expression s, for example, h times x squared plus d times y squared plus t times w squared. So this will be our expression, t times w squared plus h times x squared plus d times y squared. So that is a command if, let's say, we want to find out what are the symbolic objects within this expression s. So we can use the command find sim s, for example. When we press enter, MATLAB says that d, h, t, w, x, and y are the symbolic objects in this expression here. And this is just for you to know that this command is still available, but later find sim command will be removed in future MATLAB release. So it says here that use simvar instead. So let's try that command, simvar of s. When we press enter, now MATLAB says that d, h, t, w, x, and y are the symbolic objects within the expression of s. So if let's say we want to find simvar of s comma 5, if we put 5 in the command here, s comma 5, which means that MATLAB will display 5 symbolic variables in default order. So we have here x, y, w, t, and h. So d will be omitted from the answer because we only requested for 5 symbolic objects. We can also use, for example, simvar 1, when we press enter, we get the default symbolic variable. So basically, x is the default symbolic variable in this expression S. Okay. Now let's look at the collect command. Say we define x and y as our symbolic object, and we have our expression S that is equal to x to the power of 2 plus x minus the exponent of x times x plus 3. So this is our expression. When we press enter, MATLAB automatically rewrites this expression that we have entered up here. MATLAB displays x plus 3 times x minus exponent of x plus x to the power of 2. So when we give a command f, let's say we define a variable f that is equal to collect S. So what MATLAB does is that we can see that by using the collect command, MATLAB chose x to be our default variable, and then MATLAB will sort the variable of x according to decreasing power. So we see that x to the power of 3 is in front, followed by 4 times x to the power of 2 plus 3 minus exponent x times x. This will be 3 minus exponent x will be the coefficient of x, and in the end 3 times exponent of x without the variable of x. So here is basically x to the power of 0. So this is what collect command does. It will find the default variable and then it will sort it according to the decreasing power. Let's take a look at another example. Say we have t expression t is equal to 2 times x to the power of 2 plus y to the power of 2 and times x plus y to the power of 2 plus 3. So this is our expression that we have entered up here. And if we define a variable, let's say g equal to collect of the expression t, now MATLAB will return an expression. MATLAB will select x as our default variable, and it will sort the expression according to the decreasing power of x. So we can see here 2 times x to the power of 3 is the first expression written by MATLAB, followed by 2 times y squared plus 6 times x to the power of 2. So now these are all the coefficient for x to the power of 2. And then we have y squared times x, and then y to the power of 2 times y to the power of 2 plus 3. This is the last term that is displayed in the equation of g. So that is the collect command. We can also define our default variable. In this case, MATLAB always chooses x as its default variable. Now let's say we want our expression to have y as its default variable. So I define another variable h that is equal to collect of expression t. Now I put a comma y. So we want MATLAB to choose y as the default variable. So when we press enter, we see now it sorts the expression t, the original expression t up here, according to y with a decreasing order. So we have y to the power of 4 plus, these are the expressions, the coefficients times y to the power of 2, the second highest order to the power of y, and then in the end 2 times x squared plus x plus 3 without y. So basically this is y to the power of 0. So this is sorting the equation with respect to y. This is sorting the equation with respect to x as a default variable. So we can use the collect command to sort according to our preferences, sorting the expressions. Okay, that is what the collect command does. Let's look at another command. Now we have the expand command. Okay, now we define our symbolic objects, for example ax and y, and we define our symbolic expression x plus 5 times x minus a times x plus 4, for example. So MATLAB will rewrite our expression here to become minus a minus x times x plus 4 times x plus 5. So now we want to expand this. You see that these are all within brackets. So we want to expand by using the expand command. So I define a variable t here. T is equal to expand of s. For example, when I press enter, now you see MATLAB automatically expands this expression here to become 20x minus 20a minus 9a times x minus ax squared plus 9x squared plus x to the power of 3. Okay, we can also type in the expression within the expand command. For example, expand sine of x minus y. We directly type in the expression. So when we press enter, we see the answer given as cos y times sine x minus cos x times sine y. Okay, so that is the expand command. Let's take a look at the factor command. Now let's say we have a symbolic object of s and we have the expression s equal to x to the power of 3 plus 4 times x to the power of 2 minus 11x times x minus 30. So this is our symbolic expression, x to the power of 3 plus 4x squared minus 11x minus 30. So we can simply use a factor command to factorize the expression s by typing in factor s. When we press enter, we see the answer given as x plus 5, x minus 3, x plus 2. So these are the answer, the factor of the expression that we have defined up here. Okay. Now let's look at another command. We have also for symbolic expression a simplify command. Now let's say we have we define x and y as our symbolic object, and we have the expression s that is equal to x to the power of 2 plus 5 times x plus 6 divided by x plus 2. Okay, this is our symbolic expression. And let's say we want to define a variable as a that is equal to simplify of s. We want to simplify this expression here. So when we press enter, we get sa is equal to x plus 3. So basically what we have written up here is equal to x plus 3. So MATLAB automatically simplify the expression that we have defined by using the simplify command. We can also use simplify command by typing in the expression directly within the command. So we type in, for example, x plus y divided by 1 over x plus 1 over y. Okay, so when we press enter, we get an answer of x times y. So this simplify command simplifies the expression that we have given up here to become a simplified expression of x times y. So that is the simplify command. There is another command that we can use that is known as pretty command. Let's see what this command does. So let's define symbolic objects A, B, C, and X, for example. And we have our expression S is equal to square root of A times X squared plus B times X plus C. So this is our symbolic expression. Now if we do pretty S, MATLAB will display this expression in a math format that we can easily see. For example, here we have square root of ax square plus bx plus c. We can take a look at another example like what we have previously. For example, this one. So say now S is this, x cubed minus 4x squared plus 16x divided by x cubed plus 64. If we do pretty S, you will see that MATLAB returns this form here, this format, x to the power of 3 minus 4x squared plus 16x divided by x to the power of 3 plus 64. So this is what the pretty command does. It will display the expression in mathematical formats that we are familiar with. Okay, now let's see how can we solve algebraic equation using symbolic math. Okay, let's say we define our symbolic objects A, B, X, Y, and Z. So to solve an equation, we can use the command solve. We can define h as our variable, or you can use any variable that you like. So h, in this case, I define h as the variable. So h is equal to solve of exponent of 2 times z, for example, minus 5. So this is our expression, symbolic expression, and we want to solve this expression. When we press enter, we'll get the answer of log 5 over 2. This is the solution assigned to the variable h. We can also, for example, define an expression s is equal to x squared minus x minus 6, for example. So we have x squared minus x minus 6 as s. Now we can solve this. Let's say I assign to a letter k. K is equal to solve s. When we press enter, we see that k is equal to minus 2 and 3. So basically, in this particular expression, the solution to this expression is minus 2 and 3. Okay, we can also type in we can also type in the expression within the solve command by using the strings. Okay, equation is typed in as strings. For example, cos of 2 times y plus 3 times sine of y is equal to 2. Okay, so this is our expression. We have cos 2y plus 3 sine y is equal to 2. So we would like to know what is the value of y. We can use the solve command. When we press enter, we see that the answer given is pi over 2, pi over 6, and 5 pi over 6. So these are the values or the answer of y. And there's a warning here that MATLAB will not continue the support of character vectors. to create symbolic expression, first create symbolic variables and then use operations on them. So MATLAB prefer that we define our expression first. For example, I will just copy this. I will copy this, and instead of equal to 2, we're going to make it minus 2. Okay, and then what we want to do is we will use a command solve A, so we will still get the answer, the same answer that we have we obtained up here. So instead of writing it is equal to 2, we type in as minus 2, because we bring this 2 here to the left hand side, so it becomes this. Or we can simply type in directly. For example, we type in like this, and instead of equal to 2, I put in minus 2, like that, and when I press enter, we'll still get the same answer like what we have up here. So let's take a look at a few more examples. Say we define our symbolic objects A, B, and X, for example, and we have an expression of T is equal to A times X to the power of 2 plus 5 times B times X plus 20. So this is our expression, and let's say we do solve T. We will get these two answers here. Okay, this the equation is of T equals to 0 is solved for variable X, which is the default variable in this case. So this is solving this expression up here for X. So this will be the value of X. We can also solve for another variable. Let's say we want to solve for A. So what we do is that, let's say I assign a variable m to this. So I want to solve the expression T, comma A. We put a comma A there, which means that MATLAB understands that we don't want to solve for X, but this time we want to solve for A. We want to find out what is the value of A. So when we press enter, we get another answer, that is m is equal to minus 5bx plus 20 over x squared. So this is in terms of A. So basically A is equal to this. Up here, what we get is what is the value of X when we solve T. When we do not define any variable, MATLAB automatically solve this for T. Okay, we can use the solve command in MATLAB to solve simultaneous equation. So for example, let's say we have we define x, y, and z as our symbolic objects, and we define a few equations. Let's say, for example, this, we have A is equal to x plus 5y minus 3z equals to 10. See that there are two different equal signs here, as we have already mentioned in previous class, that one equal sign means that we assign something to a variable, and this double equal sign means equal. So in this case, we assign this expression to A, and in this case, this here means that x plus 5y minus 3z is equal to 10. So we write another equation B, for example, minus 5x minus 3y plus 2z equal to minus 20. And we have another equation C, that is equal to 2x plus 2y minus 3z equals to 12. So in this case, we have three equations with three unknowns x, y, and z. So we can solve this. We can solve these expressions, these simultaneous equations for x, y, and z. There are two methods to solve this. The first method is by typing in within a square bracket x, y, and z. That will be the output of this expression. So solve x, y, z equals to solve of now the expression name a, b, and c, a, b, c. When we press enter, we will get the answer x is equal to 59 over 19, y is 7 over 19, z is minus 32 over 19. These are given in exact form. Of course, if we want to know what is the approximated value of x, we can always use the command double x. So we get the value of x equals to 3.1053. That is the first method. The second method is we can type in, for example, an for answer. This is our variable an is equal to solve a, b, c. When we press enter, we see that the answer is given like this, as a structure with fields x, y, and z. There is no answer being displayed. So how do we know what is the value of x, y, and z? We type in an dot x, we press enter, we get the value of x. We type in an dot y, we get the value of y, and if we type in an dot z, we get the value of z. And of course, if we want to know the approximated value, we can always type in double an dot z. For example, when we press enter, we get what is the value of minus 32 over 19, we get minus 1 over 1.6842. So there are two methods to solve simultaneous equation in MATLAB. The first one, this is called the cell array method. We will get the answer in form of an array x, y, and z. And the second method is known as the structure method. We will get this in form of a structure with fields, okay? And to display the answer, we type in the variable dot x, dot y, and also dot z.